we have seen WPF and the architecture of WPF. Let's go ahead with some of the classes which are there in the WPF. Now, when we create a WPF application, the WPF application is run under two threads. One of the thread is called as a rendering thread. The other one is called as the dispatcher thread. The rendering thread is used to render the components which are there on the form, and it is not available for the programmer. Whereas the dispatcher thread is the only one that is available for you to interact with the WPF application. However, there is one problem with the dispatcher thread, and that is dispatcher thread is only one thread. It will not span itself into other subthreads. And if at all you want to interact with the elements that you have created on your form, you will have to interact via this thread. So it will not accept any other the request from any other thread. So what is in a simple way, what I mean to say is all your components, whatever components that you are creating has to be associated with this thread, and you can directly interact use to this thread using the other thread. Okay. Then how do we interact with the components? If it is not allowing us to interact with the other threads, or it is not allowing the other threads to interact with this thread, how do we go about it? For that, we have this hierarchy, and right at the top, we have within this hierarchy, we have object. Everything is derived out of the object. The one that is shown in the rounded rectangle are all abstract classes. The others are concrete classes. I will go through all of them one after the other. Let's start with the dispatcher object. Now, what does this dispatcher object refers to? By the way, let's if you look at here, this is an abstract class. You cannot directly create any object out of that class. I've told you that entire UI is held by one thread, and you cannot interact with the UI using the other thread. In that case, how do you send the messages to the component? So when I type something on the text box, the thread that owns the text box is not available to me. It is a separate thread. Then in that case, the keyboard input or the mouse input, how do you send it to the other thread? Naturally, you have to send a message to the other side. So only way you can interact is send a message to the other side. And this system.threading.dispatcher object is a object that dispatches the messages to the component. So when you type something and when the some event has to be transferred to your component, this is the dispatcher object. You put it inside the dispatcher object, give that dispatcher object to the other side, and it will take it. So this is how it goes. The next one is the dependency object. Now, this is responsible for creating the dependency properties, as well as it is responsible for creating the attached properties. Now, let's recall what we have done in when we created the grid and the other one. So we had something called as a grid. I won't write the entire thing. And somewhere within the grid, what you have done is you created a button, if you recall. And in this button, you told grid.row equal to 1. Something of this type. Now you'll notice that the button has many properties. Okay, and when you created the dock panel, you again said button dock panel dot dock equal to top, left, right, and so on and so forth. Now you notice that the button does not own this property. So this property is not part of the button. This property was part of the grid, or this property is a part of the dock panel or something else. But button takes that property and then start using it as though it is its property. And that is what is called as an attached property. So button attaches a property of the other component and uses it. Now, this idea is not there in any object-oriented paradigm. So in any object-oriented paradigm, you don't say that one of the object takes the property of the other object and starts using it as its own. Such a notion is not there. If you want the properties of the other object, then you have to inherit from the other object or do something do some tricks in the hierarchy and get those values. Here it is not that. You have a grid that does its own work. You have a button that does its own work. But suddenly the button says, I have a property called as a grid.group. And how this magic is performed is using dependency object. The work of the dependency object is to provide that functionality wherein the other component or the other object takes the property of something else and uses it as though it is its. The other reason why we use this dependency object is for the dependency property. Now you can say within very soon we were going to see that thing. You can have a text box and you can tell that this text box gets its value from a database. So you have a database here and you can say within the particular field of a database it retains its value. So in other words, you are saying that the value of this text box is dependent on something else, and this is called as the dependency property. Again, you can extend it for event triggering and animation and data binding. We are going to see this data binding and animation very soon, and you will be when I tell you what is the animation, I won't explain about how this dependency property will come into picture, but definitely you are going to see that. Let's go ahead with the next component within the tree. Let me go here. So dispatcher object is used to dispatch something to the thread. Dependency object will help you in the dependency. The next one is the visual, and let's go back to this visual. The word itself says the use of this visual object is to show the content onto the screen, or in other words, provide a representation to all the components which you have. So it may be a button, it may be a circle, triangle, whatever you draw, or it may be a list box, it may be anything for that matter. Show its appearance on the screen. Naturally, it has some basic functionalities to show the component on the screen. At least you know very well. You studied something like Presenation algorithm, wherein you say that I want a line and all the pixels within the lines are generated. So there is some algorithm that does that thing. Similarly, this particular object or this particular, remember, by the way, again, let me quickly go back. Visual is an abstract class. It's not a concrete class. It has all the properties wherein it shows, it helps the component to show itself onto the screen. The other additional properties that are associated with it are clipping and opacity. You're familiar with the word of clipping. In the graphics, you've studied what is a clipping. One important thing about the visual class, this object is, let's recall what we have studied in our previous class. We had 3 layers here. The top layer was the managed layer, and the bottom layer is the kernel of the operating system, and in between you had the milcode, that is the media integrated layer. Now here you have all the WPF component, here you have the direct 3D support, and your component, the buttons, that whatever you call, has to somehow interact with it. And in between, I told you that there is an integrating layer that takes your component from the WPF and integrates it to the kernel. And the visual class is responsible for doing that particular thing. So it is the one that provides the link between your object and the kernel which is there on your system. So once you have, these are the primary components which you may not directly interact. However, the others you are going to interact. The next on the hierarchy is the element, and the word itself says these are the elements that you can use it. So visual helps in getting the visual representation. For example, if you try to do a button, it gets that rectangle shape of the button. It helps in doing that thing. Apart from that, when I click on the button, something has to happen. And that extra support is provided by the UI element. So UI element add additional functionalities to the elements which are there in your WPF. Okay. Apart from this, it also helps in arranging the components on the screen. Suppose if you have more than one component, suppose if you have 2 buttons, how do you arrange them? that within the uh, window that is provided by the UI element. What the UI element will do is it will check what is the length and width of the particular width and height of the particular component, and then it checks how much space is available for all the other component, and then takes a particular layout and arranges it in a particular format. The next it is the framework element. Now framework element adds additional functionalities to it. So you have the button here or a text box. For example, if you have a text box, it UI element will provide all the facilities of the text box. Now if I want to connect this text box, if I want to bind this text box to a database for that matter, this is an additional functionalities. Or if I want to animate for that matter, that is some additional functionality that is provided by the framework element. So it extends the layout feature that is provided. For example, it may provide you with the binding, animation, and styling. So extra functionalities that are added. That is not really absolutely required, but you may like to use them within the context. Now, once you have this framework element, the other are the one that you usually interact with them. Let's look at all the other one. Just below this hierarchy, what you have is shape. Now, what is, let me get it. What is a shape? Shape is an element that is derived out of a framework element. And you can have different types of shape, like rectangle, ellipse, path, and so on. If you want to venture into all your graphics, whatever you have studied, the basic curve and all the others in the third semester, all the components can be created directly using this particular class. So these are the basic classes that helps you to draw the different shapes within the different geometric shape on your screen. And this functions or these classes or these objects can be associated with the other component. For example, I have shown you even in the lab wherein I have placed a ellipse or a rectangle. I don't remember whether it's an ellipse or a rectangle inside a button. So within a button you can place this component. The next within the, by the way, all of them are siblings. Whatever I'm talking are the siblings of the framework element. The next one is the control element. When you have studied your Visual Basic, you might have learnt about controls. And what are the controls in Visual Basic is, in the Visual Studio, on the toolbox, whatever you get are all of them are controls. So you drag anything from the toolbox and place it onto your form, everything is a control. However, that notion is not true in WPF. Everything that you drag from the toolbox and place it onto the form are not controls. What is a control? A control is a component with which the user interacts. Suppose if the user does not interact with that component, if the user cannot directly interact with that component, then it is not considered to be a control anymore. So what is a control? Something with which the user interacts. There is one other important thing about WPF, and the important thing about the controls are lookless. They don't have any appearance of their own. So whether it's a button, whether it's a scroll bar, whether it's a list box, it does not have any of its appearance. Then when you dragged a button, you got that rectangular button like appearing structure. How did it appear? It appeared because the button can support a template. So the appearance of the button is because of the template. You change the template, the appearance of the button changes. You change the template of a list box, the appearance of the list box altogether changes. So when somebody says it's a control, the control has its behavior but not its appearance. So the control, the button knows that there is a click event, on top event, on press event, and so on and so forth. All the things it is known to it, but button does not have any appearance of its own. The appearance comes because it tries to implement one of the template. You change the template, the button changes altogether. So what's the advantage of this? You have seen the button which are rectangular in shape. You can create a style of this type, and then give this style to the button, then the button will appear like this. So you can change the appearance of any of the control uh, according to your wish by changing the template. And today you are going to see in the lab how easy it is to change the template of any of the control and make it appear differently from the old dull looking appearance. Okay, let's look at the other one in the control. Now I'm going to go to the other type of the control. One type of the control that you are already familiar with, the label button, toggle button, and so on. The other type of buttons are called as item controls. Now the word itself says, what is the meaning of saying items control? Is a control that handles or that has many items inside it. One of the simplest example is the list view. List view can contain list of text inside it. A menu can contain number of items inside it. A toolbar can contain many of the buttons inside it. All of them are derived out of the items control. And what can be there within this item control? Anything. The list box by default has a list of text or a text boxes or text inside it. If you want, you can change the list box and make it contain the list of images. So instead of the text, you can display the list of pictures inside it. Again, if you really want it, you can change it and then say that you can have a list of pictures as well as a list of text inside it. So anytime you want, anything you want, you can do it. So they are all flexible. The last part of it is the panel. The panel is responsible for laying the controls, and we have seen the different types of panels like stack panel, grid panel, and so on. We will say it in depth today itself. So what are the different panels? Now panels are the containers. They help in placing the controls in a proper layout. So that is the last part of it. So let's quickly recall what are the things which are there. Right at the top we have the dispatcher object. The work of it is to dispatch the messages to the different objects. We have the dependency object that helps in, I don't get the mouse pointer. The dependency object that helps in providing the dependency properties or the attached properties. The next one is, by now you may be a bit confused, what is the dependency property and attached property. Very soon when we talk about the data binding, you will come to know that what I'm talking about. Then we have the visual. Visual is a representation of the showing the component onto the screen. It has the crude methods for drawing the controls onto the screen. Slightly below it, we have the UI element. UI element adds additional functionalities to them, such as the event handling functionality, data binding functionality, and so on. The next one is the framework element that has still extra functionality like for animation and so on and so forth. Below this are all the components that you can think of using: the controls, the panel, the shape. Okay. So let's go to the other one, and that is called as the XAML. Let's see what is a XAML. XAML stands for Extensible Application Markup Language. Pronounced as XAML, it's a declarative XML-based language that is used to define an object and its properties. This is not a new thing that you are studying, because in the last semester when you use the Android, you have just realized that the GUI is created separately, the code is created separately. And I've told you in the last year itself why that distinction is there. So you know very well there are two types of people. One is the people who are interested in developing the application and who are not the designers. And the other type of people are the designers who are interested in giving a good look and appearance to the application, but they don't know how to code it. Okay. So both of them, you don't find a person who is good at both of them. So either a person is good in designing the artistic way, and the other person is good in developing the logic. Now when we build an application, we want both of them. Now in the olden days, what used to happen is both of them were working on the same forms. The designer wants to make the appearance neat. The developer wants to code a efficient algorithm. So it was always a problematic, because when the designer is handling the form, the code can't type any code, and when the coder is typing something, designer is out of job. Now, what was the alternative for this is keep the designing part separately, keep the coding part separately. If you look at the ASP.NET for that matter, the ASP.NET tags are separate. The code behind is a separate file. In the XAML also, you have the XAML part is separate, the designing is separate, the C# code is a separate file. So what's the advantage? Designer can anytime use the expression blend, design a beautiful looking image or a beautiful looking window or the form, and the coder can happily type the code without bothering about the design, provided they know which component they are trying to use it. Okay, so that's the reason the XAML came into picture. So it is much easier to quickly develop any application with the designer and the developer doing it simultaneously. Now, what is the use of this particular XAML? XAML is a declarative language like your HTML or any other language, wherein you declare the existence of an object and its properties. When you type something in the XML, no magic can happen. XML is an XML by itself. There is a parser that goes through the XML and then converts it into the equivalent C# object. And suppose if you were lucky enough, when you used the XAML, and if you have made a mistake in the XAML, a terrible mistake in the XAML, the Visual Studio itself will give you a warning, and it will not show you the entire XAML and say that I cannot pass this because something is wrong in this XML. If you were lucky, you will see that. It will not show you the preview of the form and then says there is something critical wrong, somewhere you missed one tag or something. I cannot parse this XAML and I can't create the equivalent object. So whenever you type something in the XAML objects are converted into equivalent C# object. So what does this mean? It just means to say that if you are developing a WPF application, you don't have to have a XAML with you. If you are not happy with the XAML, you can code your application without the help of the XAML. You can create an instance of button by saying button be equal to. So you can do this. If you are a hardcore programmer, you can say button btn is equal to new button, and then specify the properties for that particular button, for the list box, and so on and so forth. Okay. But the effort that is required in hard coding this component and placing them in a proper layout, at least you know very well. You have done some Java coding, and wherein somebody might have asked you to create a form in Java or an applet in Java, and you know very well what is going to happen if you take that task in the programming. Your layout will not be proper, you'll not be able to put the buttons at the proper locations, and because you will have to mentally visualize where the things are going to come, and it is very difficult. So what is the other alternative is use the XAML, make the layout properly using the XML, which is much easier. You have just seen how easy it is to develop something in the XAML. Then finally associate those components with the C#. So when you type something in the XAML, you're typing the XML, the parser will go through the XML, converts it into the equivalent C# object, then onwards you can use them as though everything was there in the C# itself. Let's look at one of the important component in the WPF, and one of the component is the panel. So panels are meant for laying out the visual elements, and you have seen there are different types of panels are there, and how one panel is different from the other is how it lays out its children or child element within its container. So let's look at how many different types of panels are there. We have stack panel, we have wrap panel, we have dock panel, grid, and canvas. So there are different types of panels are there. Some of the words may be equivalent to your Java world, and they behave, in fact, they are the same kind of behavior that you get even in the XAML. Let's look at the stack panel, and let's see how to build a stack panel. In order to build a stack panel, you have to use the tag stack panel and stack panel. Within this, you are supposed to place the component. Component could be anything. When I say anything, it could be one more stack panel. So instead of this button, I can put one more stack panel inside it. So I can nest it. It is not a big or it's not a new thing. Okay, here, if you notice the stack panel, When I put the component, the first text box saying that text panel demo, it comes right at the top. You are familiar with the stack. You studied, in fact, you have written the algorithm for creating the stack. So stack is placing one component on top of the other and on top of the other and so on. But when it comes to the stack panel, you are not placing one component on top of the other. Instead, one component is placed below the other. So the first button comes top, the second button is below this. So it's slightly different. It's like a stack, but it's like an inverted stack. So you place the component one below the other. Okay. The one problem with the stack is when you keep on placing the component on this stack, if you put the component in this stack for that matter, so you put one component here, one more button here, and so on. Once the end of the visual screen is, or once the end of the form is reached, if you place one more component, you won't get any error message. It will simply stack the component, even if it is not visible. So you must be very careful with that particular thing. So this stack grows from the top to bottom, and I will talk about the other one. The problem with the stack is it will not wrap the controls. For example, you know very well in the any Word document, when you keep on typing like this, when it reaches to the end of the screen, automatically the next word is wrapped to the other side. Whereas the stack panel will not do that. It will keep on placing the element on the stack. If the element goes beyond the visual screen, it will simply keep it on the other side. Then you may have to provide either a scroll bar or anything to make those components visible. Okay. Now let's look at how the elements can be placed in this stack. The element within the stack can be placed in three ways. The one is from the top to bottom. So you can place like this. So this is one appearance from top to bottom. From left to right you can place it. So this is one way. So you can place the element like this, one after the other in this direction, or in the reverse direction. So you can start from here and then place the next element next to it, next element next to it, and so on. However, you cannot do this one. From the bottom up is not possible. You can't keep one element bottom, next element on top of it, on top of it. It is not possible. That option is not available. So the orientation for this stack is top to bottom, left to right, right to left. It's not the orientation, it's called as the flow direction. You are already used the stack panel, by now you are already familiar. Let me show it in the diagram. So the default stack behavior is top to bottom. If you want to change the appearance from left to right, just make the orientation horizontal. When you make the orientation horizontal, the button 1 will come here, button 2 will come here, button 3, button 4, and so on. When you make the orientation horizontal and the flow direction right to left, the button 1 will come first, button 2, button 3, and button 4, and so on. So this is the other appearance. So this is the appearance that will come like this. This is this kind of appearance where you start from here and place the element. The other one is this where you put the top element. But you notice that there is no way you can place it like this. The stack that you are already familiar, that orientation is not possible. You don't have that option. For the horizontal, you don't have the flow direction. The flow direction is applicable only for the this option. When you make it as a vertical, that flow orientation is not available. Let's the other, I think I've already talked about it. So you cannot stack the element bottom up, and the other one is stack grows without the bound, even if it grows beyond the visible edge. So when you keep the element, it keeps on adding the element. Even if the element goes beyond the screen, no exception is raised. It simply dumps the element. That means you must be very careful to see to it that the elements that you are putting in this stack is not going beyond the screen. It will not help you to get those components. Now, what's the essential difference between a stack panel and the wrap panel? the stack panel is not wrapping the element, whereas the wrap panel is like a stack panel with one extra facility, and that is the wrapping. So it will wrap the component. For example, here you have the wrap panel. The button 1 is placed, button 2, 3, 4 are placed. Button 5 cannot be shown in this area, so it is wrapped to the next line. Automatically it wraps it. You don't have to tell it. When it goes beyond the screen, automatically it takes it back and puts it onto the next available location. Okay. The rest of the things are same as that of the stack panel. It is like a stack panel with one facility, and that is the wrapping facility. Okay. So here you notice that the orientation is horizontal and the flow direction is from left to right. Naturally, you can get the other type of orientation, and the way in which you can get the other type of orientation, I'm going to just show it, which is much easier. So you can have the flow direction from left to right, and if you say the orientation is horizontal, then button 1, button 2, button 3 will come, button 4 will be wrapped to the next line. If you say the orientation is vertical and the flow direction is from left to right, then it is this one. So button 1, button 2, button 3, button 4. After that, the button 5 can't be shown here. It is wrapped to the next column. The same thing is true if you do it in the other way around, from right to left. So it will start from right, and when it reaches to the extreme left side, it is wrapped to the other side. So after button 3, button 4, 5, 6, and again it's going to wrap it. The other way around is you are starting like this, the vertical orientation. Button 1, button 2, button 3, button 4. Button 5 can't be shown here. It's going to wrap it to the other direction. So you can have different orientation. The good thing about it is you can adjust the width of the component. So here you notice that all the buttons are given the size that is required, automatic size, depending upon how much space is required. The width are automatically adjusted. If you want to change the item height and width, you can do it. I'll just show you an example here that will make the things much easier. So what is told here is item height is 90. So you are saying the one item will, again I press the button, one item will occupy the width of this region from here to here is 90. The next set will come again 90. So the buttons, the components will be placed. So you are just saying